Okay, students, we're going to go over right triangle problems, mostly SohCahToa. These are former problems from the DCAS. All right, in the right triangle shown, Trish wants to estimate the degree measure of theta. She knows that A is somewhere between 10 and 11, and B is between 5 and 6. So we need to test all those boundaries. Now, since this is theta right here, then we know this is the opposite side, this is the adjacent side, and this is the hypotenuse. So every time it's opposite over adjacent, which is tangent. So it's tangent of theta equals the opposite, go 5 over 10, and we could have 5 over 11. We could have 6 over 10, and we could have 6 over 11. We need to test all of those. So how do you solve for theta? It's the inverse tangent. That's how you get rid of tangent, inverse tangent of each of these numbers. So I'm not going to keep writing inverse tangent. Okay, it's going to be inverse tangent of all those. So pull out your graphing calculator. What's the first thing you should do with your graphing calculator? Change it to what? Degrees. Remember, by default, when you come onto the DCAS test here, it is, you have to know that the calculator is right here in the middle. Click on it. You can then clear that. You can drag it to the right. Don't forget this exhibits on the right here. That's your formula sheet. You cannot ask for that. Ask where those things are on the test. I need to go to mode immediately and change it to degrees. Okay. Hit enter. So I can quit, go back to the main screen. Okay, now I can go ahead and do those. So let's see if I can move this over here. Okay, so we can get those numbers in there now on the screen. Okay. So we have inverse tangent, second tangent, inverse tangent. We have 5/10 or 0.5, same thing. 26.6, round to the nearest tenth. Okay, next one. Inverse tangent of 5/11, 5 to 11, 24.4. Next one, 6/10, inverse tangent of 6 divided by 10, or 3/5, 30.96, go to 31.0. And last one, second inverse tangent of 6/11, 28.6. Okay, so what is the low? 24.4. The greatest and least estimates, 24.4 to 31 degrees. Okay. And you just explain this in the box. Just write down all those numbers that we just calculated right there. All right, next one. I need to make this smaller. Let's go 150. Okay. So triangle RC, cosine of R. So cosine of R is 3/5. So that's adjacent over hypotenuse. So that's 3/5. That makes this 4 for 3, 4, 5 Pythagorean triple. Find the sine of t. So if I'm at t, sine is opposite. Don't forget, if I change it to t, this now is the opposite. This is the adjacent. The hypotenuse never changes. So the sine of t is opposite over hypotenuse 3/5. So there's my answer, 3/5. Whenever it's asking for sine of t or sine of the angle, it's always a fraction. Okay. Next. A 30-foot ladder. Okay. Bottom is 1/4 of the length of the wall away from the wall. 1/4 of the ladder is 7.5 feet. how far up the wall will it reach? So we want the height. That's Pythagorean theorem. So I have 7.5 squared plus h squared equals 30.5 squared. You need to make sure you're showing your work so you don't blow free points. This would be a calculator problem, so you have a calculator. You just got to type that in. So h is the square root of that. Okay, so now I just plug that in the calculator. Square root of 30.5 squared minus 7.5 squared. Enter 29.6. So 29.6 feet. And what's it say to round to the nearest foot? So let's see. 29.5 makes it round up to 30. Okay. So nearest foot would be 30 feet. Okay, since we're going to nearest foot, which obviously makes no sense. The hypotenuse is always along the side. That's why it isn't actually that long. Okay, this one, they want to find the angle the ladder makes to the ground. So they want you to find that theta right there. Now, don't forget, we cannot use this 29.6 because that's a rounded answer. You have to use exact answers, which are the two they gave you, the 7.5 and the 30. So from this theta, that angle right there, this is the adjacent, this is the hypotenuse, so it's a cosine of theta equals 7.5 over 30. So solve for theta makes an inverse cosine of 7.5 over 30. Okay. All right, so now you put in the calculator. Inverse cosine, 7.5 divided by 30. 75.5 to the nearest tenth. Round to nearest degree. So what was that? 76 degrees then is the nearest degree. If you mess up on your rounding, you get marked wrong. So if I put 75 instead of 76, did all the right work, but rounded wrong, boom, lose everything on that part B there. All right, part C. The bottom of Sam's foot is ladder 6 feet from the wall and is leaning against it. If Sam was to move the ladder 1 foot further away, which obviously then would be 7 feet, which of the listed statements is true? So you want to see what happens at the top of the ladder, which is the height of the building. Okay, obviously the height's going to go down. It's not going to go up, so you can wipe that out. It's going to move, obviously. So we're down, does it go down by 0.22 or down by 1 foot? Okay, so we had 6 feet and we had 7 feet. Okay, you can do Pythagorean theorem. Okay, so that'd be 900 minus 36, and it's the square root of that. And this one is 900 minus 49, square root of that. That's their two heights. Okay, and so what are those answers? 900, oops, square root. 900 minus 36, 29.4, and 900 minus 49. Oops. 900 minus 49. 29.17, which is 29.17. So that was down by 0.22. That was a 3.9 there. We rounded up 0.22 feet. There's my answer right there. Okay. Part D. Is 6 feet from the base of the wall and is leaning against it. If Sam moves the bottom of the ladder 1 foot further away from the wall, which of the listed statements is true? The angle the ladder makes to the ground, so that theta Okay, so we have theta right there, 6 feet, 30, and theta right there again, and this time 7 and 30. So again, that's adjacent or hypotenuse. So it's going to be theta equals inverse cosine of 6/30 compared to inverse cosine of 7/30. Okay, playing the calculator. Inverse cosine of 6 divided by 30, 78, and inverse cosine of 7 divided by 30. So what it changed by? Almost 2 degrees, basically. It's basically 2 degrees difference. That one says 3 degrees. That one says 1 degree. This one says 2 degrees. There's my answer right there. Okay. Next. It says the door of the building is 7.5 feet tall. So that right there is 7.5. All these sheets of metal are equally distant, so 7.5 divided by 3 is 2.5 each, 2.5 feet each. I count up how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And I can split that in half, 22, 23. So there's basically 23 sheets times the 2.5. 23 times 2.5 is 57.5 feet. So the height of the building, 57.5 feet approximately. Okay. Which is what's the best estimate of the height of the building? That's that one. Explain your reasoning. We did 7.5 divided by 3, got 2.5 right here. Count up how many there were. There was 21, and then we estimated that this would be about 2 of them. Might be 1.5. Then put it down to 57 feet. So that's close. Right there. You just explain that reasoning. Okay. And the assumptions we made, our assumption is that this was going to be 2 sheets, or if you want to say 1.5, you can say 1.5. What's the minimum bucket arm length the repairman needs to reach the roof? Round your answer to the nearest foot. Explain how your work. So this is already 6 feet off the ground right here. Okay, so we know that's 6 feet. So we subtract off that 6 feet, and we get 51.5 right here. Okay, and we want to find out how long what's called H for hypotenuse, how long that needs to be to reach that 51.5 using that 70-degree angle. That's the max it can go. So that's opposite over hypotenuse, which is sine. So the sine of 70 equals opposite over hypotenuse, cross multiply, H sine 70. This trig function always goes last, the variable out front. And I still have one last step to do from pre-algebra, divided by the number to get the variable by itself. Sine 70 is just a number. Okay, so put in the calculator, we're saying to round to nearest foot again. So 51.5 divided by sine 70. 51.5 divided by sine 70 equals 54.8, which is 55 feet, because we want to go to the nearest foot. Okay. And then enter your work, and you put this in the box. You put all that stuff in the box. Okay, here's a similar problem. Gives you that information. We won't do that one because it's just like the one we just had done. What's the approximate height? So again, in the angle of elevation, just so you know, angle of elevation is that theta. So if I hear this right here, that's 70 degrees, that's the angle of elevation. So it'd be asking what's that degree? Okay, and then it wanted that height. Okay, to get the height, we just do Pythagorean theorem. 225 squared minus 100 squared square root. So the square root of 225 squared minus 100 squared. Bring it outside. Enter. 202 feet would be the approximate answer. So 202. Where do we see that? Right there. And now we want the angle measure of theta. We know that is, where do I go? Back here. And down. So that's we can't use that h we just found because it's approximate. We have to use the exact answers, which are those two right there. So adjacent over hypotenuse. So cosine of theta equals 100 over 225. Solve for theta, which means I do inverse cosine on both sides. And now I just plug in the graphing calculator. Plug it in. Inverse cosine of 100 divided by 225. 63.6. What did it tell me to round to? There's that 63.6 right there. Okay. A student stands 50 feet away from the front of the building and measures the angle of elevation to the top of the building. Okay. From the student's eye level, 5 feet off the ground. This is that tree one I gave you on your SohCahToa test. The angle of elevation to the top of the building is 30 degrees. Approximately, what is the height of the building? Okay. So I have this building. Okay. He is 50 feet away. He's standing and he's 5 feet off the ground, so it's short kid. Okay, maybe an 8th grader. Okay. And the angle of elevation to the top of the building, that's that angle right there. Remember, this is 5. We'd have to add at the end. The angle of elevation is 30 degrees. Okay. That means this is 60. So now we have a special right triangle, don't we? So we can, if we wanted to, we're going to have to use that, right? Because we only have an angle in this. No, and we could use trig. Okay, so we want that height right there, and then we'll add the 5 on. So we have tangent h or x over 50 of tangent of 30. So I have tan 30 equals h opposite over adjacent, cross multiply, h equals 50 tan 30. Okay, that's much quicker than to do, well, I mean, if you know this would be divided by root 3 because it's a 60-degree side, so you get 50 root 3 over 3. Okay, so that's what the height is right there, plus the 5. Okay, we'll see that we get the same answer for both. There's that answer, and we'll see in the calculator in just a second, and we should get the same thing here. 50, 10, 30. 50, 10, 30. 28.9. Okay, which is 29 feet. And let's say we get 50 root 3 over 5. Oh, wait a sec. Sorry, what did we forget? That's just the h plus the 5 plus 5. So that's 33.9, which is 34 feet. Okay, which is what we should get right here. Okay, 50 root 3 divided by 3. 50 root 3 divided by 3. Enter. Plus 5. 33.86. Same one, which is then 34 feet. Okay, same answer. So here we use special right triangles, and here we use SohCahToa. Okay, right here now. Figure shows right triangles drawn on the inside of a rectangle. That means there's 3 similar triangles. They're all right triangles, so they're similar. Okay. The sine, so this is the longer side. So P, and going up from the right angle, P matches up with K, because this is the longer side, and this one going up from the right angle, K. And on this one, that would be M, the longer side in this right triangle. So P, K, and M are the same. Therefore, J, R, and V are the corresponding. Okay, select from the drop-down menu. So the sine of P, okay, that over that would equal the cosine of V. Remember, the count matter is the same thing as the cosine of V in that one. P matches up with K, so that's the same as saying the cosine P is same as K. So the sine of P, oops, matched up with K. So the sine of K, what is the sine of K? Opposite over hypotenuse here. Okay. So the sine of P equals the cosine of V. So V matches up with R, and what's the other one? J. R and J. Okay. So therefore, it's going to be the cosine of J. Remember, those are complementary angles. So the sine of one equals the cosine of the other. The cosine of K equals the sine of what? It could be the sine of R, but what are the other R's equal? R's equal J and V. So we're looking for J or V. And there's V right there. Okay, so guaranteed that type is on the DCAS. All right, all three of these are similar. Okay, so find the values of cosine of F. The cosine of F. So we got to see B, F, and I are the same. Okay, cosine of F equals the cosine of B, which equals the cosine of I. Now, don't forget the cosine of F right here would also equal the sine of E. So those are true. The cosine of B, 15 over 17 equals the sine of C. And that one, complementary. The cosine of I would be the sine of G. Now, that's just for you to remember, those are the complementaries, like we just did in the last one. So all of these are equal to be able to choose from. But notice in this one, they only use the cosine ones. So I'm just picking the cosine ones. Okay. So cosine of F. F goes along with the cosine of B. The cosine of B is 15 over 17. So we're looking for it to be 15 over 17. Okay. Which wipes out 8 over 17, 8 over 15, 8 over 17, 8 over 15. That equals the cosine of F. Yes, it is. Cosine of F is right there. So that's true. And the cosine of I, which is true right there. Okay, so you've got to be able to go back and forth like that, set those up. Those are different ways of doing the same type of problem. The length of a ramp is 25 feet. Boom, there's my ramp. The ramp needs to rise 1.3 feet. There's my height, it needs to rise. Which the following is the closest distance in feet from the walkway to the base of the library? So they want this length here. So what do you do? Pythagorean theorem. 25 squared minus, what was it? 1.3 squared. 0.3 squared equals that, and we can take the square root of it. Square root of answer. You can use second negative sign for answer. Saves you that. You get 24.99 or 96. That's basically 25 feet. 24.9697. Right there, 24.97. There you go. Okay. See all this trig. You got to know your trig. That's why I'm making this whole video, to go through all these types. For each trigonometric expression, indicate if the expression is equivalent to the measure of angle A or the measure of angle B. Drag and drop the measure of angle A or the measure of angle B into each box. So, let's see. ABC. Okay, so your typical A, B, C, C is usually your hypotenuse. Okay, right there. So little a, remember that side opposite angle A, that's little b, and that's little c. You need to be able to draw that. So which one is A, or it says, which one will give me what if the sine is A over C? This over this. Okay, what angle am I finding? Which one is this sine? Sine, that's if it's angle A, right? Opposite over hypotenuse is sine. So that's angle A. So I put that down angle A. Which one is calculating A over C with cosine? The cosine of B gives me A over C. So this is B. Which one is tangent A over B? So it's A divided by B, because it's opposite over adjacent. That tangent is from angle A. And which one is B over A? Well, if I do tangent of B, that is B over A right there. So that's B. Okay, you've got to be able to draw that out and do that kind of stuff. Know your sine, cosine, and tangent. Okay, part D. So if it's going to be 3 feet instead, approximately what will be the measure of the angle of elevation of angle A? Okay, there's my theta, angle of elevation. Okay, so what is that? Opposite over hypotenuse, sine of theta equals 3 over 25. Solve for theta, that gives me inverse sine on both sides, 3/25. Plug it in the graphing calculator, inverse sine of 3/25. Inverse sine of 3 divided by 25. 6.9, which is 7 right there. Okay. All right. Here, this has been one on. I watched this actual problem on one of the ones that our kids took. Okay. Let sine of B equal R. So the sine of B, remember that means we can write R as R over 1. So sine of B, remember that means opposite over hypotenuse. So the opposite is R divided by 1, and there's hypotenuse. The cosine of B is adjacent over hypotenuse. So I have it over 1. So the hypotenuse is 1. Yes, that's true. So the adjacent is S. Okay. So now we have those sides filled in. You have to be able to do that. Now it says, what's the sine of C? The sine of C, remember that's opposite over hypotenuse. S over 1 is S. Minus what's the cosine of C? Adjacent over hypotenuse, R over 1 is R. So it's S minus R. C. Okay. Gotta be able to do that. All right. Remember, this is the angle of depression, which is congruent to the angle of elevation right there. B at an altitude of 1,000 meters. Remember, altitude is the same thing as height. You need to know that. You've done that on your DCAS sheet. Altitude and height, same thing. Directly above point D. So that should also tell you on the floor. Point A represents the location of a small fire. At the moment in the time represented by the figure, the angle of depression, that's this one right here, is measured 30 degrees. Part A. What's the distance in meters from the UAV to the fire? So it wants that distance, because there's the fire. Okay. So that's X. I'm going to use this triangle right here. It's 30 degrees. It's opposite over hypotenuse. So sine of 30 equals 1,000 opposite over hypotenuse. Cross multiply X sine 30 equals 1,000 divided by sine 30. 1,000 divided by sine 30. Oops. 1,000 divided by sine 30. 2,000 feet, or meters, 2,000 meters right there. What's the distance to the nearest meter from the fire to point D? Now they want that distance. Okay. Well, remember we have a special right triangle there. I could have just used special right triangle. I didn't even have to use that. That's the 30-degree side. The hypotenuse is double that, 2,000. I could have done that real quick, 30, 60, 90. I didn't have to waste my time with this, even though I got the same exact answer. Okay, so now I know that this distance is the 60-degree side, which is root 3 times longer. So it's 1,000 root 3 is the exact answer. But they want to nearest meter. That means the ones spot. So I put 1,000 root 3 in my graphing calculator. 1,000 root 3. And I get 1732. We're going to nearest whole number, 1732. Got to be all around correctly. Okay, so there's that answer. Now let me erase all that. Part C, we have this information there. The field of view of the camera is, so this is my altitude. Okay, the field of view of the camera is 20 degrees. It's represented by the figure in angle CBE. CBE, this right here, is 20 degrees. It's insane. Okay. What's the approximate width of the forced floor that will be captured in this picture? So that would be that distance right there they're looking for. So it's splitting it. Okay, 20 degrees, so that means each one's going to be 10. This is isosceles. It's going to go out the same, so that means these base angles are congruent. This is 10, so therefore this down here is 80 degrees. Okay. What do we have height-wise? What are we using? I guess we're supposed to, oh, we'll just keep using that 1,000 is the height. Okay. So I can find one of these side lengths, so I'm just going to blow that triangle up. So this height is 1,000. This is now 10 degrees, splitting that 20 in half. We want this right here, okay, and then we'll double it for the whole length of EC. So that's opposite over adjacent, so that's tangent. Tangent of 10 degrees equals opposite over adjacent. Cross multiply, x equals 1,000, 10, 10. Look at the graphic calculator. 1,000, 10, 10. 176.3. 176.3, double that. Okay, 175 would be 350, so 352.6. Okay, and what did they say? 352.6, obviously is going to be 353, right there. Okay, it's flying at a speed of 13 meters per second in the direction toward the fire. 30 degrees there, 30 degrees there, so that makes it 60. The UAV is now 800 meters. Suppose the altitude of the UAV is now 800. So there's your altitude, 800. The new position represented at point F in the figure. From its position at point F, how many minutes to the nearest tenth of a minute will it take the UAV to be directly over the fire? So we want to be finding that distance, which is the same as this distance right here. That's what you're trying to find. Okay, so first you need to find that. Okay, that's the 30-degree side. So how to get the 60 multiplied by root 3. So it's 800 root 3 is the exact distance. Okay, 13 meters per second. Okay, so it says, notice, it says how many minutes to the nearest tenth of a minute will it take the UAV to be directly over it. So if it's going 13 meters per second, okay, and we need to convert to minutes, So that's times 60. All right. So 60 times 13 is 780 meters per minute. Okay, so you can go 780 meters per minute in 1 minute. Okay, the total distance he has to go is 800 root 3 minutes. So do 800 root 3 minutes divided by 780, and that will tell me how long. So 800 root 3 divided by 780. 800 root 3 divided by 780. Answer is 1.78 or 1.8 seconds. Boom. I mean minutes. We're in minutes. 1.8 minutes. Okay. Next. This one has been on ours for our students right here. Okay. Theta is the angle right here. Okay, part A, when theta is 28 degrees. So now they've told you it's 28 degrees. What's the distance from point A to point B? So now they want that right there, A to B. And we already know that length is 3. So that's adjacent over hypotenuse. Cosine of 28 equals the adjacent over the hypotenuse. Cross multiply, x equals 3. I'm skipping a step, divided by cosine 28. You gotta skip that step in between, but when we solve for x, that's you get 3 divided by cosine 28. 3 divided by cosine 28. Oops. Come on, enter. What the heck is just froze on me? Okay, let's clear all this out. What just happened here? Clear. It froze on that. Okay. 3.4. 3.4 feet. Nearest tenth. 3.4. When the spring is stretched, the distance from point A to point B is, so when this gets stretched right down here, remember that was just 3.4. Now it's going to be stretched and that distance is 5.2. What is theta? Remember this 3 feet doesn't change. So now we have adjacent over hypotenuse, which is cosine. So cosine of theta equals adjacent over hypotenuse. Solve for theta, inverse cosine of 3 divided by 5.2. Inverse cosine of 3 divided by 5.2. 54.8. Right there. Okay, all this is SohCahToa over and over again. You'll identify things. Okay. How many do we got to go? That's 10. A few more on page 10. Okay. All right. Probe travels 3,900 meters. An angle of depression, 64.7 meters to the team's ship. Okay. So it shows select the drop-down menus to complete the sentences. When the probe reaches the ocean floor, the probe will be approximately blank meters below the ocean surface. So that means it wants that height right there, the altitude. We know this is 67.4. Alternate interior angles are congruent. Okay, and we know the hypotenuse, 3,900. So it's opposite over hypotenuse. So it's sine of 67.4 equals opposite over the hypotenuse. So the hypotenuse equals 3,900 times sine of 67.4. Plug in the calculator. 3,900 sine of 67.4. 3,600 meters. So that's what you'd be choosing down below there. Come on. Move that over there now. Okay. when the probe reaches the ocean floor, the horizontal distance of the probe to the team's ship on the ocean surface, the horizontal distance, that's that from there to there, is what? So now I want you to find that. Again, I cannot use h because that's an approximate answer. We're going to use, call it x, and we'll use the 3900. So that's adjacent. So that's cosine. So cosine of 67.4 equals adjacent x over 3900. So now x equals 3900 cosine 67.4. 3900 cosine 67.4. And that's approximately 1499. They might have 1500 there. Okay. But otherwise 1499. They'd probably say 1500 for you to choose from. Okay. Now we're back to similar triangles again. Okay. Which represents the tangent of h. Okay. So again, h is the same as q. So the tangent of h equals the tangent of q. So I go over here at q, the tangent of q is the opposite over the adjacent, or if you get confused, hypotenuse is always across from the right angle, so you should identify that first. So the tangent is 8 over 15. Should be 3 points, as long as you don't mess up identifying H, O, and A, and making sure you use corresponding angles right there. The degree measure of the angle in a right triangle is x. The sine of x, sine which is opposite over the hypotenuse, is 1/3. Which of these expressions is also equal to 1/3? Okay, so if that's x, don't forget this is 90 minus x, because those are complementary. So that wipes out these other ones of 45 minus x. Okay. So does this, and we'll just call it angle x, and we'll call this angle y, and that z, for example. So which is equal to 1/3? It'd be the cosine of 90 minus x, right there. The cosine of this angle is also 1/3. It's not going to be the cosine of x. The cosine of x, I see that's 9. That's 3 squares. 9 minus 1 is 8. That's the square root of 8. So the cosine of x is square root of 8 over 9. That's not the same. Okay, so it's only that one right there. Unless they had others that I didn't see. Okay. I didn't copy down. All right. These are the same, all the same that we've already done, so I'm not going to do those. Wheelchair ramp, we already did a ramp one. Is this the same one? Tangent H is tangent Q. Yeah, that's the same one. Oh, they just changed the numbers. The tangent H goes to Q. Tangent, oh yeah, opposite 8/15. That's the exact same problem. I copied it again. Okay, 27. We'll do that one. That one is actually, I saw that on our students one. So you're now finding the height of the tree. So I have to find this height with this triangle, and I find this height with this triangle down here, and then add them together. Call it h sub 1 and h sub 2. Okay, here's just given the information right here. Okay, what's the height of the tree? Like I said, we find this h from this top triangle, find this h sub 2 in the bottom triangle, add them together. So we have opposite over adjacent. So tangent 42 equals h over 20, and tangent of 31 equals h over 20. And then we add those together. Okay, so h sub 1 equals 20 tan 42, and h sub 2 equals 20 tan 31. Put them on the graphing calculator, add them together, and there's your answer. Enter it in the box. In the box, it must tell you what to round to here. Okay, 20, 10, 42. 20, 10, 42. Parentheses, plus, let's do it all in one. 20, 10, 31. Add it together and get 30.02, so about 30 feet. If that's what it is, 30 feet. Okay, that's what they're probably looking for. Very easy. Right triangle, WXY. Okay, and F is 90 degrees. So if F is 90, then the Y is 90. That matches up. So that means this has to be Y, W, X. And then we have another one, DEF. F is the, and D matches up with W. So D has to be here. F matches up with, D matches up with W. F matches up with Y. E matches up with X. All corresponds. Okay, it says DE is square root of 113, so you can put that in there. DF is 7. EF is 8. Okay, which expression represents, and so that's 64 plus 49. So you can see you get 113 and then square root of 113. So that is true. Which expression represents a cosine of W? Well, don't forget W matches up with D, so it would also be the cosine of D. Okay. Cosine of W match up with a cosine of D, which then is adjacent over hypotenuse 7 over square root of 113. Right there. Okay. Got to be able to go from one triangle to the other. Guaranteed to be on the DCAS. Seen it every year, each year. Okay. The distance from the campsite to the tower. Campsite to the tower. That's what you're trying to find. Okay. So what we need to do here, we see in this triangle, we have degrees, we have the adjacent side, and we're looking for this height, which then we can use with the big triangle on the 55 degrees to get x. So it's adjacent, opposite over adjacent, so it's tangent of 72 equals h over 400. H equals 400 tan 72. So this equals 400 tan 72. Notice I didn't put an answer in there at all, because that is the exact answer. I didn't put a decimal answer in there. I'm going to leave the exact answer. So now I'm using this big triangle. Or I taught you we don't round and do approximate answers because that puts you further off. So leave the exact answer there. So now we have the big triangle, and that's the opposite over the hypotenuse, which is sine. So the sine of 55 equals the opposite, which is 400 tan 72 over the hypotenuse x. Cross multiply, x sine 55 equals 400 tan 72. Last step, divide both sides by sine 55. This is just pre-algebra steps, or algebra 1. If you want to say that. And then now we can approximate that final answer, because we got exact answers right there. And it wants it to the nearest foot. So I'm going to type that in the calculator. I'm going to first do the whole numerator, get that answer, and then take that answer and divide by sine 55. Okay, 400 tan 72. Oops, 400 tan 72. Get that answer. Take that and divide by, what was I divided by again? Sine 55. Sine 55. And we went to the nearest foot. That'd be 1503 would be our answer. Nearest foot, 1503. Okay, read the directions. And there you go. All right. So right triangle, C is the the right angle. A and B says cosine of B, which is adjacent over hypotenuse. Oh, we have a 5, 12, 13 Pythagorean triple right there. That's why you know this. Memorize your Pythagorean triples. Which function also equals 5/13? Well, if I go from A, it would be the sine opposite over hypotenuse, the sine of A. Boom, right there. In the diagram below, measure of angle T is 90. They have these numbers here. What's the measure of angle S, the nearest degree? Okay, well, it's going to be adjacent over hypotenuse, so that's cosine. Cosine of theta equals 60 over 65. Okay, now if I recognize this is about each by 5, that's 13, that's 12, so that's a 5, 12, 13 Pythagorean triple multiplied by 5, so this would be 25. Just practicing our Pythagorean triples and finding that other length. Okay, just to keep that fresh in your head. Inverse cosine of 60 over 65. And just put in the calculator. Nearest degree, that's a whole number. Inverse cosine of 60 divided by 65. 23 degrees is going to be the answer. Right there. Nice and easy. Okay, this is like our first one with our ladder leaned against the building. You just draw it instead of it having drawn for you. All right, we got through it all. Okay, let's stop that. 51 minute.